this lesson. Yeah.
Awesome. Let's hit the road. Okay, so starting from last week, I've just written down a random hyperbola here. And so I want to ask someone to explain to me, if someone's brave enough, to come on and just tell me a little bit about this hyperbola, some of the stuff that you know about this hyperbola, or yeah. So maybe someone who's feeling brave, pop your hand up. And again, it's not about being perfectly right. I just want to have a conversation around how you would think about this hyperbola. And Kanyezi, let's come to you. How's it going?
So the way I think of formulating a hyperbola, especially, is I would usually, in my opinion, I usually like start with the asymptotes. I look for that point of symmetry.
Okay.
I look for a point of symmetry in which I can draw the things properly.
Yeah.
And as well as that, I also look to see what is my A value.
Yes.
Because if it's above 0, if the A value is above 0, then that means that it starts in quadrant 1 and quadrant 3, and then vice versa. If it's negative, then
can I even start? Because you're doing so well. I even look at, you don't have to, but I even look at the A value first, and I ask myself, if it's positive, I know it's going to be in those two quadrants like I'm showing. And then if it was negative, it would be in the other two. Would you agree?
Yes, I would agree.
Tell me about these asymptotes. Do you know what the asymptotes are for this hyperbola?
Yes, when it comes to the asymptotes, I think about the y asymptote specifically.
Okay.
Because A is either less than or more than 0, then it would mean that the fraction cannot equal to 0. Therefore,
okay.
y cannot equal to -1.
Okay, so basically,
it's a really roundabout way of getting to that answer, but that's how I think about it in my head.
So basically, you would say that the y asymptote here is going to be y equals -1. And so when I think about it, I just think it's this number at the end. It's shifting the graph down by 1 unit. And that's the way I think about it. But you're right, there's multiple ways to do it. I always think, you know, like the standard form of a hyperbola, and I'm sure Miss Coco would have talked about this, or she may not have got to it, but it's like that. I think of the plus q as shifting it up or down. And so the plus q basically here is shifting this whole graph down by -1. That's with a y asymptote. Can you tell me about the x asymptote? Because that's a bit trickier.
Oh, with the x asymptotes, it's well, it's just that it cannot equal to q. It's the inverse of q. It can, you're not q, I mean p, sorry, p. So it's always yeah, it's the inversion of p. It can't, if p is positive, then it's negative plus the value.
Exactly. So I kind of was talking about this a little bit with parabolas, that when we deal with the x, it's almost like it always goes to the opposite process or the opposite thing. And so if it's a -2 here, it will be a +2. Or another way of saying it is to say, look, what number would cause division by 0? If I put a 2 in here, 2 minus 2 is 0, and that's not a good thing. Or basically an asymptote occurs
and
place when it happens. Yeah. Go for it.
Oh, the third one.
Yeah. So what would the last two things you have to do to find if you wanted to draw the hyperbola?
The last two things would be would it be the intercepts?
Yeah.
Yes.
Exactly.
Well done.
So basically, I think of a hyperbola as a three-step process. And the good news is, to find the intercepts, we can use the same ideas that we used before. Okay. We just have to basically work out those things. Now, I'm not going to do that now, but that calculation you would have done in the previous lesson. So basically, when I draw this hyperbola, what I do is I know roughly what quadrants I'm in, but then I start by anchoring in my basically my asymptotes, and then x is 2, like this. And so I'm assuming this is kind of what you guys did in the last lesson. And now you know that basically my hyperbolas are going to be, there's the quadrant 3, 1 over there. And here's the quadrant 1, 1 over there. And so the only difference is that because of the shift, the actual Cartesian plane almost looks like it's moved, well, it's moved 2 units to the right and it's moved 1 unit down. And so that is what I'm assuming one of the lessons you did last week was about that. So I just want to check, does everybody feel comfortable drawing a hyperbola, or do we still feel, do we need a bit more practice on the mechanics of that? So thumbs up if you feel very comfortable, thumbs down if you're like, I still need a bit more practice on this. Okay, I'm still going to do some practice. It's just how much we do. Okay. So it's a big mixture. So basically what I want to start with then is to say, whenever we draw a hyperbola, you could make it more steps, but basically it's these 3 main steps over here. It's the A value and determine what quadrants we're in. It's the asymptotes, and then it's also the intercepts. And then we can go from that point to actually draw a graph. And when we draw the graph, we put the asymptotes down first, and then normally we would put intercepts in, we'd label them, and then we draw the graph through here. Okay, so we'll do a bit more practice with this. The other thing I want to point out is that the standard form of a hyperbola is this bit up here, where we have an A value, and then these things over here, that's the vertical shift, that's the horizontal shift. Okay, let's just go with some basics then to start with.
Sorry, before we continue, Kanyezi, I think, has either a question or something to.
Okay, Kanyezi, go ahead. Yeah.
Wait, so is it acceptable to also allow it to be y equals a over x minus p plus q? Because in some cases it will be minus p. Okay,
so the standard form has a plus p, but that p can be positive or negative. So that's how you deal with it. Okay, you're going to see this in a moment when we do this practice exercise.
Okay, thank you, sir.
Pleasure. Let's go and look at this. So I'm going to give you these 5 functions, and you are going to tell me the asymptotes for each of the following functions. I will do the first 2 for you as an example. So this is a hyperbola. How do I know it's a hyperbola? Because the x is below the fraction line, or it's in the denominator. Same thing here, same thing here. So these are all of them are hyperbolas. If you want to find the asymptotes, there's always going to be 2 asymptotes. In this case, the x is going to be x equal to 0. And that's because that's this one here. And over here, the y asymptote is just going to be y equals 0 because of that, the plus 0 on the end there. For the second one, the x asymptote is going to be the number that causes division by 0 over here, or it's a plus 2. Basically, it's going to end up being x is 2. All right, and then over here, it's going to be the y asymptote is y equal to 1. So if you are trying to answer the question, what are the asymptotes of the hyperbolas? These are like the lines that if I had to draw them, they are the dotted lines that basically can't be crossed. So like over here, if x is 2 and y equals 1, if I was drawing this graph, x equals 2 would be over here, and y equals 1 would be here. So this is what I'm finding out. I'm not drawing this graph, but I want you guys to tell me the asymptotes for these 3 hyperbolas. And I just want to make sure everybody can identify hyperbolas, the asymptotes for hyperbolas. So in Tokozo, why is x 0? Because in this very simple hyperbola, can you see there's no shift? So over here, this is a very simple hyperbola. It's just got an x in the denominator. So because it hasn't been shifted, the only number that would cause division by 0 would be when x is 0. I hope that helps a little bit. The same situation is going to be happening here because the x is all by itself in the denominator. But I just want to make sure everybody knows how to find the asymptotes of a hyperbola. But there's always going to be two asymptotes.
You are doing it, guys. You're doing it. Let's go.
And I'm just so grateful Eskom hasn't turned off the lights, but I know they're coming. In fact, let me get my camping light ready. So
I think if it passes 20 past, then you are safe. But before,
never.
Still not safe.
I live in fear. The load shedding is coming for me. Okay, so keep those answers coming. For A, the asymptote would be x is 0, and the y asymptote would be y equals minus 8. I'll give you a little bit of a sneaky helping hand over here. I'll give a plus 0 on the end. You can always stack a plus 0 on the end for B. Okay, so for B, the x asymptote is going to be 2, and the y asymptote is going to be y is 0. And what about C? So ask yourself this. If you've got x plus 4 over here, what value of x would cause division by 0? And that is going to be x is equal to minus 4. And then basically what this is telling you, if I use the translation language, it's basically this thing over here is moving the whole graph 4 units to the left. Remember, it always works the opposite way with a horizontal shift. And so this x plus 4 is shifting the whole graph 4 units to the left. The y asymptote and the y shift is much simpler. It's just going to be y equals minus 2. So why am I spending the time to show you asymptotes? Well, because asymptotes are almost like the foundation of hyperbolas, right? So the most basic hyperbola just has its asymptotes on the y-axis and on the x-axis. So if I had to give you like a hyperbola like y equals 4 over x, that would be in quadrants 1 and 3, and it would just look like that. Sorry, excuse my messy writing. But the moment we start shifting it around, the moment we start saying, oh no, this is now x plus 2, and this is now minus 4, what happens is that the asymptotes start to move around. So in this case, there would be like an asymptote at y equals minus 4 and an asymptote at x is minus 2. So you have to know what the asymptotes are to help you almost draw your graph. And you also need to understand what asymptotes are in the sense that a graph will never cross the asymptote. All right, give me a thumbs up if you're feeling a bit better about asymptotes. Thumbs down if you still feel like, what is this man talking about?
So I have learned that asymptotes is that friend that you friend zone. You know, that friend that you can never touch. I was so happy once I learned that. I was like, oh, okay.
Exactly.
Friend that you have that you cannot touch. That's asymptote.
There we go, friend zone. Okay. So what I want to do, just quickly check with you, is if you've got a hyperbola like this, I want to make sure that you feel very comfortable finding x and y intercepts. Okay. X and y intercepts, I will just do one for you, and then you're going to do two for me. So given this hyperbola, if I want to find the y-intercept, I'm going to make x 0. Okay, if I make x 0, what is going to happen? Well, let's see. I go y is equal to 1 over 0 plus 4 minus 2, which then can be written as 1 over 4 minus 2, which is going to be minus 1.75 or minus 1 3/4. So that would be the y-intercept for this particular hyperbola. Notice how I used the same rule that I use for all functions. Now to find the x-intercept, and they aren't always intercepts, sometimes there aren't any, and you'll see that in a moment, but we make y naught. So we then go 0 equals 1 over x plus 4 minus 2. Then what I'm going to do is I'm going to bring the minus 2 to the other side, and I get 2 equals 1 over x plus 4. I'm then going to bring this whole x plus 4 to the other side. And what that means is it becomes 2 multiplied by x plus 4. Actually a bit of working out, but you get there in the end. Then I get 2x plus 8 is 1. Take away 8 from both sides, and I'll get 2x is minus 7. And then I get 2x is minus 7 over 2. Wait, yeah, 2x is...
Yeah, we just have to divide both sides.
Yeah, we're going to get rid of that. So we get 2x is minus 7 over 2. So you have to be able to find the x and y intercepts for hyperbolas. So what I want you to do is I'm just going to ask you to do J. I want everyone to find the x and y intercepts for J if they exist, just to make sure that I know that you can do this. Over to you.
While they're still busy on that, don't ask a question on the chart saying, so how do we determine the curvature of the hyperbola?
Okay. So when we talk about the curvature of the hyperbola, the curvature is related to this well, this is going to be minus 5. This value over here deals with the curvature, but to be honest, it's not a major issue because of the fact that it's a sketch graph. And so as long as you've got the correct points and the graph is going through the correct points, the exact curve doesn't need to be perfect. It's beyond the scope of it, yeah.
So he meant the shape of the graph. So he corrected us just now.
Okay, the shape of the graph. How do you know about the shape of the graph? The basic shape of the graph for hyperbola looks
so like a C, like how you draw it is more of like an open C. I don't know how to
so the technique for drawing it. Okay, I think of it like a roller coaster. So,
nice.
So if you think if you're at the top, but it's a roller coaster that starts to take off again. So it gets to there, it was living its best roller coaster life, and then it just kind of starts to go up again. So it's the first part's like a roller coaster, but then it looks symmetrical.
Nice.
Okay. So I'm just going to rub out. If you need to take screenshots of the example. But I want to make sure that we can do the next one. Okay.
Screenshot time. Okay, gone.
So for the y-intercept, I'm just going to make x naught which should be let's just make sure that we're on the right track. I get y as 1. it up a little bit. Okay. I'll give you a little bit more time to see what you get to. I'm getting a y-intercept of 1, and I'm getting an x-intercept of 1/3. And that is all related to question J. So I'm wondering, are there any questions from students? I think probably students are still looking at the working out. Some of the issues I can imagine where students might have got caught is when they were multiplying the -3 and the -1 together. That may, remember that you got +3 there. And then
Signs were a little bit of a problem, yeah.
okay. Give us a thumbs up if you're feeling okay with the working. Give a thumbs down if you feel like you're quite confused about this. Okay, so what I want to make sure is that if we had to draw, I'm not going to, well, maybe I should draw it. For J of X, let's just see if I had to draw the whole graph. Imagine I was doing the whole 3-step process. So let's say step 1, I looked at my 2, which is my A value, and I know that I'm in those 2 quadrants. Step 2 was my asymptotes, and I know that my asymptotes were going to be X is 1 and Y is 3. And how do I know that? Well, I'm looking at over here and over here. And then the third step was my actual intercepts, which we've just done now. So because I wasn't with you, I just want to make sure you know how to actually draw this graph. So to draw J, what I would do is I would start by drawing my Cartesian plane, and I would pop my asymptotes down. So let's go with, apologies guys for that there. So X is 1. And then the next one is going to be up here. And this is going to be Y is 3. Now that comes directly from over here. And those are kind of the anchors for my, my graph. Now I know that the graph is going to have one part over here. And the reason I know that is it's in quadrant 1, except the quadrant 1 has been shifted up. And then I have another one, and I might have drawn it a little bit wrong here because I've got X. No, I had that right. I've got that. And remember, I have to have an X and Y intercept that I label. And so the X intercept was 1/3. Actually, let me zoom in a little bit. So the X was 1/3 and the Y intercept was 1, which makes sense, which is over here. So it's a little bit messy. And then the equation of the graph was J. And so if I had to draw my hyperbola, that is basically how it would look. And so I just wanted to take a moment to show you that process for drawing hyperbolas. If you would like to do another practice with y-intercept and x-intercept, give us a thumbs up. If you want to move on, give us a thumbs down. Oh yes, intercausal. Intercausal, the graphs, the hyperbolas are symmetrical, and we need to still talk a little bit more about that. Okay, it's quite a mixture.
Well, I say so far the maths is mathing, so all good.
Oh, good. Okay.
I agree.
So when we deal with hyperbolas, we deal with something that I haven't spoken about yet, but I will speak about later, is that not only are there things called asymptotes with hyperbolas, which is the dotted line over here, and I never cross those asymptotes. There is something called an axis of symmetry. So it almost looks like you can fold the hyperbola. Like if you imagine a line going through here, you could fold the hyperbolas across that line. And there is also an axis of symmetry that goes like that. It's almost like those two blue lines would cut the hyperbola in half. And so we would call those blue lines the axes of symmetry. And what's really important about them is that they go through the central point over here. And I want you guys to write down for me in the chat, what is this point over here? What is the coordinates of this point over here? Because later on in the lesson, we're going to use that. And it's where the two asymptotes meet, but it's also where what we call the axis of symmetry goes through. What's the coordinates of that point? What's this going to be? The asymptotes can guide you. Abnejo has got it, and I see Nkanyezi. So you're right. It's in line with x is 1, and it's in line with y is 3. So the point of intersection, that's a fantastic word, of the asymptotes is the point 1, 3. And that point 1, 3 is going to be on the axes of symmetry, which is something that I've just thrown out at you now. But I just want you to notice it, that it's almost like the green graphs can be cut in half very nicely by the blue lines. Does it ever need to be calculated at some point? In Tokoso, it does, but I will talk to you about it later. Let's build our house on a good foundation. Okay, so what have we done so far today? We've gone over the basics of hyperbolas. We've looked at some of the basics, and now we've sketched a hyperbola. Is the point of intersection PQ? Okay, Dawn, let's not get too obsessed with that for now. Let's just stay with the idea, can you find the asymptotes? Can you find the point of intersection visually? I don't want to go into the memorizing quite yet. Cameron, the axis of symmetry is not the same as the asymptotes. They're different, but they do both go through this really important point over here. Okay. But before we do anything more, what we need to do is we need to have a stretch, guys, because our brains need some blood and we need some oxygen. So I want to stand up and I want Yolanda to tell me which student is doing the best stretch. I will do my best to get in the race.
Let's go, guys. My eyes are itchy. Let's go, guys. I see Nompa. Nompa, I'm joining you, girl. I'm just like stretching. Because it's not the pop quiz today. Today is the polls day. Kolwani, I see you. I see you. Stretch. Karabelo, our new guest in the house, our newbie, we welcome you. Do the stretching. Zoma, I see you.
There we go. You can do it.
Yes, guys, it's very good to stretch.
I'm going to stretch. Oh, there we go. Feels so much better. So much more live and
wearing shorts. I'm freezing in here.
Remember, I'm in Cape Town, you're in Joburg.
Yeah, true. Different world, indeed.
Different world, yeah. Okay, let's do a quick brain break just to let our brains like this have a little break. So, some angry birds, there's a bee, and there is a monkey. Something I want to point out, because we've had some debates about this in the past, that there are 3 monkeys over here, whereas there's 1 monkey over here. I want to know what a monkey minus an angry bird times a bee is. Over to you guys. Let's do it. Okay, and remember, I'm after this. Yeah, I'm after this one over here. Be the best you can be, guys. Be the best.
Don't fall for the trap.
Eskom, I'm still worried Eskom's going to strike, but I think now life must be smiling at us.
No, you win. They will never get out. It's been more than 30 minutes, so you're safe.
So it feels like the bird is 4. And so I'm going to put 4s throughout. Okay, so if that's the 4, now the B is indeed 3. So many students are saying the B is 3 because 9 times 4 is 36. So we have to deal with what these 3 monkeys are and then what 1 monkey is.
Cameron on our faces. Our Cameron is telling us that he hasn't had any load shedding for days now. Our Cameron, oh,
What's going on
faces, man.
there? So 12 times 3 monkeys gives 72. So 3 monkeys must be 6, which means 1 monkey must be 2. Now, what is the final answer going to be? Let's do this.
Yeah, I think
4
I'll see
three.
the final answer already.
So BODMAS says we need to apply this last bit in one order. And what we need to do is we need to do that before we subtract. So who's got the answer? Lots of you do. Okay, so I see there's a whole bunch
They
of
already
minus.
won.
Yeah.
Yeah.
And so the final answer is minus 10. Now,
Well done, guys.
you'll see a lot of you, if you're new, we've been doing this type of problem for quite a long time. So don't feel intimidated if you take a bit longer, because we literally do this every lesson almost. But yeah, it's a fun problem that we do. Okay, fantastic. That was well done on the brain break. Just give me a thumbs up if you're still enjoying the brain breaks. Thumbs down if you feel like, I'm just interested to get a feel for the class. Thumbs up if you're still enjoying the brain breaks. We do try to mix it up from time to time, but I'm still enjoying them. And so I'm still managing to find new ones. Okay. We can find a few other problems and puzzles too, though. All right, so let's go back to where we were before. So we haven't spoken too much about domain and range. So maybe what I should do is, actually, let me go to this question over here. We'll do this one from scratch. Okay, so what you're going to do for me now is we're going to do an exam type question on hyperbolas. And so what you need to do is you're going to break down. Now, we haven't spoken too much about the domain and range, but we're going to talk about that once we've done this. So I want to give you about 5 minutes to do this question. But remember, this question is made up of question A, find the asymptotes, question B, find the intercepts, question D, sketch the graph, and then C, if you can do it, do question C, otherwise we'll do it together. All right, over to you guys. This is like a typical exam type question. Let's see if you can do it.
Let's do this, guys. Look at there, it has the marks. So we put
Over to you guys.
marks in the
and then
back, guys.
if you want to discuss a part of this, then what we can do is you can raise your hand or you can put a question and we'll discuss it. But I think this is 5 minutes to see how much hyperbolas, how good of friends you and hyperbolas are.
We can do this, guys.
Be all that you can be. Nobody have any questions? Otherwise, we'll just support you.
Yeah, definitely. You have explained it so well, Teacher Peter. Thank you. And we understand now. Right?
Pleasure.
But remember, you're allowed to try and see if we can answer the questions, or the first one, please.
It's nice to see all the questions coming together. Like we were doing little pieces. It's nice to see them all together in one exam question, because this is how the exams do look. Okay. Carabello, let's hear your question. I'm asking you to unmute, Carabello. If you can unmute, there's a little box at the bottom. Can you hear me?
Okay, sir.
Can you hear us?
Yes,
How's it going?
I'm fine.
What's your
And
question?
you?
Very good. Very good. What's your question, Carabello?
Okay, I would like to ask if domain and range
Carabello,
of
unfortunately, your line is very weak. So
hyperbola is the same as domain and
I think
Carabello, I can just talk to you directly, okay? And also, if you would like to put your question on the chat, you are more than welcome to do so, because we cannot hear everything that you're saying, okay? Thank you, though. We still are interested on that question that you have. So just check on the chat for us, and Teacher Peter will help us or solve the problem for us.
I'm Kulani, if you've got a question. You want to go ahead? Hi, how's it going?
It's going good, sir, and yourself.
Fantastic.
So for the first one, so it says write down the equations of the asymptotes. I'm not sure. Should we write the asymptotes of the equation or?
Yeah. So basically, it's going to be the one, or there's definitely going to be an asymptote coming from that first part with the x, and so you should have your x asymptote will be x is 3. What's the y asymptote going to be?
So 1.
Yeah, exactly.
The 1.
That's it. 2 marks.
Well done.
Thank you, ma'am. I didn't understand the question.
Okay. So what basically the word asymptotes, it's knowing where they come from. And so the asymptotes, the x asymptote is always going to be coming from around here. And the y asymptote is always going to be basically the vertical shift of the parabola.
I think what is giving away the question, or why is it confusing, is because now we have learned about asymptotes, but we didn't really understand if it was equations of asymptotes.
Yeah.
Okay, thank you.
So now on to x and y intercepts, and then those who can sketch the graph, we want you to try and sketch the graph clearly. So Carabello is asking about the domain and range. Okay, I'll give you a little hint on the domain and range. Basically, the domain and range of hyperbola is going to be anything except the values on the asymptote. So when you think of a hyperbola, any x value can go into a hyperbola except one value. That one value is going to be the restriction on the domain. So it'll be easier to see with the graph. And basically, you can see it here. Any x value can go into this equation, except x equals 3 cannot go in. And so the domain of this function is going to be any x value except x cannot be equal to 3. So that will be the domain. Now the range is going to be any y value except you cannot be on the y asymptote. You may not touch the y asymptote. So I'll let you think about that for a little bit first. So I'm seeing some answers coming through. And so while you are drawing your graph, I just want to, okay, I'll give you a little bit more time. just want to check what the answers are, just so I can make sure I'm on the right track. So x is 1 and y is a third. Okay, yeah. So you should be getting the y-intercept as a third and the x-intercept as 1. I will show you the working in a moment. So y-intercept should be a third and the x-intercept should be 1. Now, if you haven't got that, I'll show you corrections in a moment, but I want everyone to try and draw the graph of this hyperbola using that information. So that's why I'm giving you that information now. Okay, and Tukozo, let's go to you. Yeah.
Hi, sir.
Hey.
I wanna ask, is the domain and range also in the graph?
You can see the domain and range in the graph, yes. So in a moment, when I show you the answer to this question, I will talk to you about the domain and range. You can see what it is on the graph, yes.
Oh, okay, thank you.
Okay, pleasure. Let me bring this bit up here. Let me get rid of this bit while you're drawing your graphs. We'll bring them next to each other. Oh. Let's see if you can see it. No, why it doesn't want to hang out next door next to this. Okay. So let's have a look at the answer. I know some of you will be feeling a little bit pushed for time. Apologies for that. But I think I'm really want to talk you through all of this nice and clearly. Okay, so let's have a look at the answers here. We all got x is 3 and y is equal to 1. Now, what you notice is that when you're drawing your graph, you should have a dotted line for x is 3 over here, and you should have a dotted line for y equals 1. So take a moment, make sure you see the two asymptotes. Okay, but now you have to work out the intercepts. Now, actually, before we even did that, if you look at the a value, so step 1, you know that this final hyperbola has a 2 as its a value, and so it has to be in that quadrant and that quadrant. Then you went ahead and you did your x is 3 and y is 1, which is what I'm showing you here. The third step was to find your intercepts, and if things went well for you, you should have got x is 1, and you should have got y is a third. So let's go and find those points on the graph. So here is the x is 1 over here, and then y is a third is over there. And then all I've done in this graph is I have my hyperbola up here, and then I have the hyperbola that goes over here. Now, what they've done is they've added an extra point on the hyperbola. And the way you can get an extra point on the hyperbola is just by subbing in an x value and getting out a y value. So you would just use the original formula, sub in an x value, and you'll get out the y value. Now, the question was about the domain and the range on the graph. So let's look at that. What are the answers for the domain and range? So you can have on this, follow me on the x-axis. On the x-axis, all of these values over here are completely fine. All of them are fine. All of them are fine. These x values are all fine. The only x value that cannot be touched is x is 3. And you could even carry on this side, because that links up to this part of the hyperbola up here. So that's why when we talk about the domain of this graph, it can be any x value. So domain is x is any real number, but x cannot be 3. And the same thing happens with the range, except the only value I cannot touch is going to be y equals 1, which is the asymptote. So y is any real number, but y cannot be 1. And the reason that is because asymptotes can never be crossed. So actually, domain and range questions are quite simple with hyperbolas. You basically say it's any x value, except it can't be the asymptote, and it's any y value, but it can't be the y asymptote. That's it. Okay. So we have 5 more minutes left, and so I want to try one more question, but I just want a thumbs up with how you're feeling. Thumbs up if you're feeling okay, and you can generally follow. Thumbs down if you feeling a bit unsure. So, a question in an exam, would we have to write it exactly like that? To the format, or can we just write x not equal to and y not equal to? Okay. I think that you could probably just say for the domain, if you said, what's the domain? And you said x is not equal to 3, that would be fine. And if you said, what's the range? You said y is not equal to 1, that's fine. Because really what you're saying is it can be anything, except it can't be this. So that would be accepted. It would be. It's just often in textbooks, students see the extra bit where we say x is any real number, but x cannot be equal to 3. So it's not wrong to write that as well. So both those things are correct. Okay.
Yeah, except when you have like a strict teacher, because your teacher will tell you, well, x is not equal to 3. Are you talking about integers only, or are you talking?
If the question says, look, if you want to be absolutely safe, but if it's for 2 marks, then you can have a debate. But if it's for 1 mark, which it normally would be, it's 2 marks in total. It's 1 mark for each. It's the restriction. So, yeah. Okay, let's finish with this last question here, since we've just spoken about domain and range. So these are all hyperbolas. But the question is not asking you, it's asking you to determine the domain and range for each of the following functions, but we're not actually drawing the graphs. I want you to try and write down the domain and range for each of these. I will do the first one with you. So the domain of this first one is x can be any real number, but x cannot be equal to 0. And the reason why x cannot be equal to 0 is because there would be division by 0 over here. The range would be y can be any real number, but it cannot be equal to 1 because the 1 would be the y asymptote, which is this 1 over here. Okay. Now you'll notice I do start by writing x as any real number, and then I exclude the asymptotes, but that's just because how I'm used to doing it. And I would say this is preferable, but I still think you would get a mark for each of these parts over here if you're really in a rush. Okay, over to you guys. I want you to try and tell me what is the domain and range for this one, and I'll call that B, and what's the domain and range for C. And then I think we're pretty close to wrapping up for tonight. So, intercausal, let's do this second one together. For the domain of the hyperbola, the domain can be any x value, except it cannot be the x value of the asymptote. So I want to ask you, what is the asymptote of the function g? Yes. So x cannot be equal to 8 would be the domain. Now, what is the range going to be for the function g, the hyperbola g? So the range is going to be y is any real number, but y cannot be equal to the asymptote, and the asymptote would have been 4. Okay, Ntokozo, go ahead. Let me unmute you if you can. Can you just unmute her, Yolanda? I think for some reason I'm struggling to.
Sir, can you hear me?
Yes, I can. How's it going?
Yeah. So you're basically saying that the range and domain are the asymptotes.
Well, so the domain and range, well, the domain is any x value except it cannot be the asymptote. So the asymptote is excluded. So, and the reason is the graph never crosses the asymptote. So it can never be on the asymptote.
Oh, okay. I see. Thank you.
Pleasure. Okay, so what we have for this next one, C, is the domain can be x is any real number, but x cannot be equal to -1. And it's important you put the cannot be equal to -1. And then the range is y is any real number, but y cannot be equal to, and we're going to go here to this -3. Okay, there's a question from Zoom user. Sorry, I don't know your name, but I'm going to unmute you.
Sir, hello, sir. I want
Hey.
to ask,
Yeah.
why is it that x is an element of real numbers and it cannot be x equals to 8, and why is it not -8?
Okay. The easiest way for you to see this is asymptotes happen when there can be division by 0. So if you look at the x minus 8, if you had to put 8 into that, would you agree 8 minus 8 is 0?
Yes.
Now, if I put -8 in there, -8 minus 8 is -16. And so that wouldn't cause division by 0. So whenever you're looking for the asymptote with the hyperbola, the trick to ask is what number would cause division by 0?
Oh,
Does that make sense?
okay. Yeah, it makes sense.
With this one, it's not going to be 1, it's going to be -1, because -1 plus 1 is 0.
Oh, okay. Thank you.
All right. Pleasure, man. Okay, Yolanda, if you could just put the poll out to the students. We're almost at the end of the lesson. I'm going to take some more questions, but we would really value you, just giving us some feedback about how you found the lesson in terms of pacing. We obviously try and do as well as we can in terms of helping as best we can. And so please, we really value your input there. So in a moment, that quiz will come out. Are there any other questions? I see Zoom user, your hand is up. Okay. I want to see if maybe if Yolanda is off the line, maybe what we can do is I can push the poll to you. Let me quickly find that wherever it's gone. And maybe we can just send that to you. Here we go. You should be getting the poll in front of you now. And guys, in the next lesson on Wednesday, we're going to continue with hyperbolas and we're going to mix them together with straight lines and other types of functions. And so, we're going to keep building our knowledge of hyperbolas. And it has been lots of fun being back with you. And just respect. Like I said this before, but the fact that you're coming and you're working during your holidays, it's being really proactive. And I just want to acknowledge your hard work. And if you keep practicing, it's like anything, you will get better and you will get results. And so I just want to encourage you to keep practicing, guys. Okay. I think Yolanda has been kicked off the